For this example, we want to use a sum or difference formula to find the exact value of the sine of 13 pi over 12. So the advantage of using a sum or difference formula is it allows us to calculate the exact value of angles that we don't find typically on the unit circle. It's not going to be a special angle that we know. However, these angles are going to be a sum or a difference of two angles that we do know from the unit circle. So what I would suggest in this problem, unless you feel really comfortable with your radian measures, is changing 13 pi over 12 into degrees, and then we can find two angles that we think that we can either take the sum or difference of. So if you recall, 13 pi over 12, if we want to turn this into degrees, we're going to multiply by 180 degrees divided by pi. So the pi cancels. 12 goes into 180 15 times. And then 13 times 15, that is 195. So we get 195 degrees here. So this is just the sine of 195 degrees. So now what we want to do is try and express 195 as the sum of two angles that we know on the unit circle. So we have lots of options. We could also use a difference if we wanted to. We have lots of options. I'm going to just use 45 and 150. So we can say that the sine of 195 degrees is equal to the sine of 45 degrees plus 150 degrees. And now, from here, we apply the sum or difference formula. So the sum or difference formula, so this is going to be a sum. The sum formula for the sine says the sine of alpha times the cosine of beta plus, because it's sum, the cosine of alpha times the sine of beta. So where alpha is just our first angle and beta is our second angle. So this is just equal to the sine of 45 degrees times, times the cosine of 150 degrees plus the cosine of 45 degrees times the sine of 150 degrees. So what are each of these values? Well, at 45 degrees, the sine has a y-coordinate of the square root of 2 over 2. At 150 degrees, the x-coordinate is negative square root of 3 over 2. The cosine of 45 is square root of 2 over 2. And the sine at 150 is positive 1/2. So just take this product. Rad 2 times negative rad 3, that's negative square root 6. 2 times 2 is 4. So we have negative square root 6 over 4. Plus square root of 2 times 1 is the square root of 2. And then 2 times 2 is 4. So that's just negative square root of 6 plus the square root of 2 all over 4. We could write it either way. Either way is fine. Often you'll see them written as a single quotient here rather than a sum of two quotients. And that's using the sum formula for the sine.